Hi, my name is Kylie and I will be here today to talk about polynomial functions. I will be walking you through question 14 on page 148 of the Nelson Advanced Functions textbook. Let's start at the beginning. What is a polynomial function? A polynomial function is an equation that consists of coefficients and variables with non-negative integer exponents that involves only the operations of addition, subtraction, and multiplication. There are different types of polynomial functions, which depends on the degree of the function. To find the degree of a polynomial function, all you have to do is find the largest exponent. So there's quadratic functions, which have a degree of 2, cubic functions, which have a degree of 3, quartic functions, which have a degree of 4, quintic functions, which have a degree of 5, and so forth. Now let's go over question 14 from the textbook. The question states, the function f of x equals to kx cubed minus 8x squared minus x plus 3k plus 1 has a 0 when x equals to 2. Determine the value of k. Graph f of x and determine all the zeros. Then rewrite f of x in factored form. Here are the steps we will take to solve this problem. First, we're going to solve for k by isolating it. Then we are going to convert our function into factored form using factor theorem and synthetic division. We will then solve for the zeros, and finally we'll graph. First off, we know this function is cubic because the highest exponent is 3. This will come into play later when graphing. The question states that this function has a 0 when x is equal to 2. This means that 2, 0 is a point on the graph. Substitute it into the equation, 2 being the x value and 0 being the f of x value, and isolate k and solve. Here is my original equation. F of x is equal to kx cubed minus 8x squared minus x plus 3k plus 1. Now I'm substituting in the point 2, 0, 2 being the x value and 0 being the f of x value. Then I am evaluating and collecting like terms, so I'm left with 0 is equal to 8k plus 3k minus 32 minus 2 plus 1. I am then going to evaluate that to get 0 equals to 11k minus 33. I am then going to isolate 11k by adding 33 to both sides. Then I'm going to isolate k by dividing both sides by 11 to get an answer of 3. Now that I know the k value, I am substituting it back into the equation. So I'm left with 3x cubed minus 8x squared minus x plus 10. Now on to step 2. We are going to factor using the factor theorem. The factor theorem states that x minus a is a factor of f of x if and only if f of a is equal to 0. Here are the steps for factor theorem. First, we must determine all the factors of the last term in the equation. In this case, we must find the factors of 10. The factors are positive and negative 1, positive and negative 2, positive and negative 5, and positive and negative 10. Then we must test each factor by substituting in for the x value. If the answer of the function equals to 0, then the tested factor is the value of a. After doing a couple of trials, I determined that the function of 2 equals 0, so therefore x minus 2 is a factor. Now, using synthetic division, we're going to find the other factor. Synthetic division is a method of polynomial division. This method only works when dividing by a linear factor. Here are the steps for synthetic division. First, you want to determine the restriction of the linear factor by setting it equal to 0. So here I have x minus 2 equal to 0, and x is equal to 2. Then you want to divide the coefficients of the original polynomial equation by the restriction of the linear factor using synthetic division. To do synthetic division, set up your equation as shown. Now bring down the 3. Multiply 2 by 3, and then add that product to negative 8. Multiply the sum by 2, and then add the sum to negative 1. Repeat this process. The last digit should be a 0 because that represents the remainder. This is because of the remainder theorem, which states if the remainder is 0, then x minus a is a factor of the polynomial. We know that x minus 2 is a factor of the polynomial, so therefore the remainder should equal to 0. The bottom line, 3, negative 2, negative 5, represents 3x squared minus 2x minus 5. This equation is the other factor of the original polynomial equation of f of x equals to 3x cubed minus 8x squared minus x plus 10. Now I know that x minus 2 is a factor, and 3x squared minus 2x minus 5 is also a factor. Now this equation can be further simplified. I will do that by substituting it into the quadratic formula. The quadratic formula is negative b plus or minus the square root of b squared minus 4ac, all over 2a. And my values are a equals to 3, b equals to negative 2, and c equals to negative 5. I substitute it all into the equation and get my values of x. Here you can see I'm just substituting my a, b, and c values and finding both of my x values. I get my values to be x equals to negative 1 and x equals to 5 over 3. Here I am just rearranging equations so they both equal to 0. My final factored equation is f of x equals to x minus 2 times 3x minus 5 times x plus 1. With this, I can now solve for the zeros. I do that by setting each term equal to 0 and solving for x. So my zeros are 2, 5 over 3, and negative 1. Since this is a cubic function with a positive leading coefficient, the end behaviors will be the same as f of x equals to x cubed. Here I have the graph of f of x equals to x cubed, and here are its end behaviors. You can see, as x reaches infinity, y reaches infinity, and as x reaches negative infinity, y reaches negative infinity. Now here is how to graph. First, you want to solve for and plot the zeros. Then you're going to solve for and plot the turning points. A turning point is a point where the graph changes from increasing to decreasing, or decreasing to increasing. Finally, you're going to solve for and plot other points on the graph. So here are our zeros. If these are the x values, we know the y value will be 0. Our points are 2, 0, 5 thirds, 0, and negative 1, 0. I plotted these in the graph shown here. The next step is finding the turning points. Again, a turning point is a point where a graph changes from increasing to decreasing, or vice versa. To find the turning points, you must start by finding the x value. To do that, you take two zeros that are directly beside each other, add them together, then divide the answer by 2. Repeat this for the other zero. Through these calculations, I found out that my x value of turning point 1 is 1 over 3, and the x value of turning point 2 is 11 over 6. The next step is substituting in one of the x values into f of x equals to x minus 2 times x plus 1 times 3x minus 5. Here, I substituted in the x value of 1 over 3, and after completing calculations, I discovered the function of 1 over 3 equals to 80 over 9. I repeated this step with the other x value of 11 over 6, and discovered that the function of 11 over 6 equals to negative 17 over 72. Therefore, my turning points are 1 over 3, 80 over 9, and 11 over 6, negative 17 over 72. The final step is to plot the points. These are where your points should be. The final step to graphing is finding other points on the graph. You want to start by choosing any x value. I chose the values of x equals to negative 2, 0, and 3. Similar to finding the turning points, you want to substitute in one of the values into f of x equals to x minus 2 times x plus 1 times 3x minus 5 and solve for f of x. Here I substituted in the value of negative 2. I evaluated it and found the function of negative 2 is negative 44. I repeated this process with the other x values and found that the function of 0 equals to 10 and the function of 3 equals to 16. Therefore, my points are negative 2, negative 44, 0, 10, and 3, 16. I plotted those points as shown in the graph here. Finally, you want to connect your points from left to right, and your final graph should look just like this. Let's review on how to solve this question. You first want to solve for k by substituting in the point 2, 0 and isolating. You then want to convert it into factored form using factor theorem, synthetic division, and the quadratic formula. Next, you want to solve for the zeros by setting each term equal to 0 and solving for x. And finally, you want to graph it by finding different points on the graph and substituting them into the original function. One occupation that uses polynomials is a statistician. They use graphs and polynomials to interpret data and draw conclusions. Now you should have an understanding about polynomial functions and how to graph them. Thank you for watching this video. I hope you learned a little bit more about polynomial functions.